All right, guys, in this video, we are going to talk about section 2.7. We should be able to do this one in just one video, so fingers crossed. Here we have example 1, and the whole idea in this section is to be able to solve rational equations and inequalities and modeling. So before we do a rational equation or a rational inequality, let's see if we can solve this polynomial inequality, because we haven't really had much practice with inequalities at all yet. So rather than start with something like very new, let's do something that's maybe a little bit more familiar. So we're going to start off with this example 1. It says we're going to solve x cubed minus 6x squared is less than or equal to 2 minus 8x. Graphically. Now, there's multiple ways that you can do this. What I think is going to be best to help us in the section we are doing is to be able to start by solving this thing for 0. I think that's going to be your best bet to prepare us for what we are going to be doing in this section. So that's the first thing I'm going to do, is we're going to rearrange this so everything is on one side. It doesn't really matter which side you go to. I'm just going to move them to the left so that I can see my x cubes being positive. But it should work fine if you did it the other way too. Your graph might look a little different, but your answer should end up being the same. All right, so I'm going to move everything to be on the left side. So I have x cubed minus 6x squared, but then we're going to add the 8x and then subtract the 2. And this is all less than or equal to 0. Now, for the purpose of putting this in the graph, we're going to actually type a y. Okay, so for the purpose of putting it in the graph, we're not going to put a 0. We're going to put a y. And you'll see why. That way we can actually graph it. Okay, so I want you guys to go to whatever graphing calculator you are using, and we are going to type that in. Okay, now you're going to see a couple things on my screen. Try not to, the brightness. People keep changing this stuff. Okay. You're going to see a couple different things on my screen if it's clear to you. I don't know. Some of it's not going to be very dark. Anyways, the top one is what I want you to have right now, is just type in exactly what we had, but instead of putting a 0 on the end, you're going to put a y. If you're having trouble getting the less than or equal to, and you're using this calculator, here's how you get to it. You have to hit this little suitcase button, okay? So as I was typing and I got to the point where I needed that, I'll get rid of it. You have to hit the suitcase button, and it's actually the very first option. So just hit OK, and it inserts it. If you want y, like if it didn't have y there, you have to hit alpha and then 3, and that gives you a y. What I want us to look at here is this graph. Now, this calculator shades very lightly up in here. Some calculators are a little bit more obvious, but this one is just very, very faint. So on the camera, you can barely see that, I think. But you see our polynomial function, and then we see there's shading that's all above that. Okay, so I'm going to kind of sketch that maybe so it's a little bit more clear. I always like to sketch my graphs. It's not going to be perfect, but I see that there's a place. Let's see. Yeah, there's a place, if we're following along, there's a place where it crosses the x-axis about here. It comes back down, crosses it again, and then way over here, it's going to cross it again. So, and what we're going to need to do is figure out exactly what those values are. Okay, but this is the graph, and then we have all this stuff above it is kind of shaded. So I'm going to get everything above the graph is shaded. That's what we're dealing with, okay? Now, it's really important that we find all 3 of these values, because those values are going to give us a little interval for what our answer is going to be. With inequalities, you don't get just one answer for x. And what we typically get, and we don't just get like 2 answers, we get a range of values, okay? And what we want is to figure out what are the range of values for x where this shaded part is hitting the x-axis. That's kind of where we're looking. So we're going to be wanting to see things on the left side, but then we're not going to include from here to here as part of your answers because it's not shaded on the axis in here. But then we will include from this point to this point because it is shaded on the axis between those two, but we won't include the tail side. So we want to see where is it shaded on the axis, and I need to know what those zeros would be. The problem with that is on these calculators, I don't know if maybe some of the other calculator versions are a little different, but these ones do not want to find your zeros when you're in the inequality setting. So what I went ahead and did is I typed in a second one. So I'm going to get rid of this one. And I typed it in just as like a function instead of an inequality. Okay, so it's just a function, f of x equals x cubed minus 6x squared plus 8x minus 2. And if we look at that graph, you're going to see the exact same graph, okay? Different color, but there's no shading. That's fine. On the one like this, all I need it to help me find the zeros. So we're going to go to the zeros finder, and we're going to see these values for x down in here. I know that's kind of small, but on the bottom left of your screen here, it shows you the values for x. So I'm going to write down the values it tells me. Okay, this one, the value for x is going to be 0.325-ish, if I round to the nearest 3 decimals. This guy over here is going to be about 1.461, and this guy is going to be about 4.214. All right, so remember we want to write in range of values where we're including everywhere where the shading touches the x-axis, okay? So it touches the x-axis, and it would forever on the left. There's nowhere on the left side of this where it would not. So we're going to say from negative infinity all the way until it reaches this point, this x value of 0.325. Okay, now they said that this is less than or equal to, so it is allowed to equal this value. We're going to put a bracket. Okay, but between these two, it does not touch the x-axis, so we're not going to include this interval. It begins touching the x-axis again over here, and between these two values, it is touching the x-axis. Again, we are allowed to be equal to these values, so I'm going to use little brackets, and this is 1.461 all the way to 4.214. There is nowhere else where the shading will touch the x-axis. After this point, it's always going to be above it, so we're not going to include that. Okay, so this is my solution. This is the range of values. Okay, so I know that's a little wild, that's a little different, but it is the easiest, I think, way to approach that problem. Okay. So here's some steps for solving rational equations. You're also going to see a couple problems here, and we're going to run through both of them. So first thing is we're going to set them equal to 0. You can sometimes get away with like switching step 1 and 2. So I do that sometimes. It just kind of depends on what my first impulse is with a problem. So sometimes I will swap those two. But these are the steps. Those are the things you want to do. Is set it equal to 0. And then we want to multiply by your LCD, your least common denominator. We would solve as we normally would a problem, because when you multiply by the LCD, it should get rid of your fractions. So then after that, you just solve like you normally would, and then you've got to check for extraneous solutions, because when you multiply by the LCD, sometimes you end up getting solutions that are not really solutions. All right, let's do a problem, right? So this first one seems very unassuming, okay, because we only have one fraction. It says x minus 4. I'm going to rewrite the problem down here just to give us somewhere where I can write on it. I'm also going to write this fraction maybe a little bit bigger, like that. Okay, this is my problem. And we're going to work on solving this. Now, this one currently is already set equal to 0, so that first step has already been done. We're not going to need to worry about it, but we need to multiply by the least common denominator. On this one, it's pretty easy to figure out what your least common denominator is because there's only one denominator. So what we're going to do is we're going to multiply the whole equation through by that LCD, okay? So I'm going to multiply the whole thing by x minus 4, okay? Now what this does, I'm going to show you, I don't normally write out all of the steps here, but I'm going to show you what it would end up being like. Because it's like this x minus 4 gets distributed to each part of the equation. So this is x times x minus 4, plus we would have x minus 4 divided by x minus 4, and then we would have 0 times x minus 4. Okay? So what happens, though, is we get to distribute here, where I would just end up having x times x is x squared. I'm going to come down here because I don't want it to bleed into the other part. X times x squared, x times a negative 4 is a negative 4x. X minus 4 over x minus 4, those two cancel each other out so that there is no fraction anymore. This is plus 1. And then 0 times anything is always just 0. And this becomes a lot more simple to solve. This is a little quadratic, and you can solve it by a couple different things, but I would suggest using, on this one, quadratic formula, because I'm looking at it and I don't see that it will factor. I'm trying to think of things that multiply to be 1 but equal negative 4 when you add them, and it just doesn't happen. So I'm going to jump over to using quadratic formula, okay? That's the whole x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'll write that out for you off on the margins, okay? So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. That's what we're going to plug this into. So we're going to say x equals the opposite of b, which is positive 4, plus or minus the square root of b squared minus 4 times a times c. This is all over 2 times a, which is 1. So let's do some cleaning. You can shorten this. You can plug parts into a calculator. That's fine by me. When we simplify the square root, we end up with 16 minus 4, which is the square root of 12. So I'm going to go ahead and write that all over 2 times 1 is 2. 4 plus or minus the square root of 12 will simplify because there's a perfect square 4. It's a factor of 12. So when you do the square root of 4, it comes out as a 2. And it was a 3 that would have been stuck inside of your radical. This 2 is going to divide into both of those at the top. 2 goes into 4 twice, and it goes into itself once. So we're just left with square root of 3. Okay, so in order to check to see if your solutions are going to be good or not, what you will do is you will end up plugging your answers into the original function. So let me make sure I'm not grabbing the wrong calculator. I have something preloaded into one. Okay, so one thing that we can do is go into your calculator and you can literally use this along with the original problem. Now I can't say plus or minus, but I can do them separately. So we can type this equation in, and then we can tell the calculator to check these values. So if I type in my calculator in here, and we use x plus, and then we use a fraction, we want a 1 over x minus 4, okay? Now it says undefined because I have not defined a value for x. But if I tell it to let x be a certain value, then we'll be able to plug that in. Now I'm sitting here thinking I know, oh, there it is. Okay. I knew it could do it, but I couldn't find the button. Okay, so what we're going to do is type in 2 plus the square root of 3. So 2 plus square root of 3. Then move out of the square root. And then there's this value. I don't know if y'all can see. There's like underneath the clear button, there's this button, and it's got a little yellow arrow on it. Okay, we want to use that yellow arrow feature. So we're going to have to hit Shift and then that arrow. And then we're going to say X. What that does is it told X to be this value. So I'm going to go back up and grab that equation, hit OK, OK, and it comes out to be 0. That's what it was supposed to equal, right? Okay, the next thing I'm going to do is I'm going to tell the calculator to be, okay, well, that's cool. 2 plus the square root of 3, that worked. What about 2 minus the square root of 3? Do the same thing and go back up and grab the equation, and it also is giving me 0. Okay, so I know it's a little hard to see under the calculator because these screens they don't pick up well, but both of those answers work. So these are both solutions. None of them are extraneous. All right, next problem. Let's look at part B. All right, part B, a little bit more tricky. Now, again, what I was saying a few minutes ago is you can work it where you leave them on the same side and just work with the LCD first. But I'm going to go ahead and swap it to where we do that step 1 where we said set equal to 0. I don't want to do things insanely different. But if you have worked these kinds of things in the past, maybe in Algebra 2, it's possible that they did do the step 1 and 2 in a different order. So that's what I'm trying to get at. But yeah, I'm going to move this stuff around. So we have 2x over x minus 1 plus 1 over x minus 3. And then we're subtracting this whole term, x squared minus 4x plus 3. Okay. Another thing is it's going to be helpful to look at this as if I factor this polynomial part. Okay, and I know you're like, oh, gross. Okay, but it's fine. You're going to deal. It's going to make it easier on yourself if you factor this guy. So I'm going to kind of just see what would this be if I did factor it. I would have an x at the beginning, and then things that multiply to be 3 but add to be negative 4. That would just be a negative 1 and a negative 3. Okay, so that's pretty simple to factor. It's not that big a deal. It coincidentally is also the values that you're seeing on these other fractions. A lot of times they build these to be that way. Do not assume that they are, but a lot of times they do build these kinds of problems to where this part will factor and use these binomials or at least one of them just to simplify the problem. So what we're going to do is we're going to multiply by the LCD. Well, this denominator is x minus 1. This one is x minus 3. So those are not the same. This one is x minus 1 times x minus 3. And actually, that is going to be the LCD in this situation. Because this guy has one of them, this guy has the other, this one has both. We're going to use the one that has both. And we're going to multiply the whole equation through by that. Okay? So here we go. We're going to multiply this whole thing through by, and I don't really have a lot of space to write this, but we're multiplying the whole thing by x minus 1 times x minus 3. Okay? All right, so look here on my next line. I'm going to write the whole thing out, though a lot of times I kind of skip this step. But we're going to have that 2x times x minus 1 times x minus, 3 over x minus 1. Okay, so that's this one. When I distribute this through to all the terms. The next one, you're going to have the x minus 1 times x minus 3 all over x minus 3. See, that top was multiplied by 1. This is 1 times all that. Over here, we have 2, negative 2. And then we're going to multiply that by the x minus 1, x minus 3. This is all over, essentially, x minus 1, x minus 3. and the other side, 0 times anything is always 0. So I know that's a lot to write, and you're like, this made it worse, but look at what happens, guys. This x minus 1 will cancel with this one. This x minus 3 cancels with this one. The x minus 1, x minus 1, x minus 3, x minus 3. No, this is not creating holes, okay? Any holes that exist would have existed from the beginning. We're not making holes or anything. So if your thought process went to that, that's not what's happening. We're just cleaning up the algebra. Over here, we have a minus 2 equals 0. So the idea is we got rid of the fractions. We're going to distribute the 2x. So we got 2x squared minus 6x plus x minus 3, because negative 1 minus 2 is 3, negative 3. All right, one more thing. We got to combine these x's here in the middle. So we got 2x squared minus 5x minus 3. And now let's factor. Okay, so here when we factor this guy, we are going to factor it into 2x plus 1 and x minus 3. And then we need to check for these solutions, because I have a solution here at negative 1/2 and one over here at positive 3. Okay, take the opposite side. If you're going to solve this, set it equal to 1, and you subtract the 1, divide by 2, negative 1/2. And then this guy is just the opposite. It's 3. Okay, so we've got two solutions here. We need to check to see if either one of them is extraneous. So we have to plug it in, always plug it back into the original equation to be sure. Okay, so I'm going to use that same trick that I was talking about a minute ago, where we're going to tell x to be a certain value. I'm going to just go ahead and tell my calculator to let x be negative 1/2. Okay, so I'm going to do the thing on here where I say negative 0.5. We're going to store this value, so hit shift and then that button under clear and x. Okay, so what we're doing is telling the calculator, let x be this. And now I'm going to type in my original, not the original, I'm going to type in this blue part, the one that was set equal to 0, and we're going to see if that comes out to be 0. Okay, that is good enough. So, because that blue part is still before we multiply through by the LCD. It's the LCD when we multiply through by that, that's what's creating those extraneous solutions potentially. So I'm going to plug it into that part that was before that step. Okay, take yourself a moment and we're going to type this all in. So we're going to have 2x over x minus 1. Then we have plus 1 divided by x minus 3. Then we have minus 2 divided by, I'm just going to write it out as the x minus 1, x minus 3. It doesn't really matter if I use the factored one or the standard form one. Okay, so we typed that in. I had already told the calculator to check for the to plug in a negative 1/2. So when I hit OK, it should give me the output, and it tells me 0. So negative 1/2 is the solution. Now I'm going to do the exact same thing. We're going to type 3, get that little store button to store this value for x. I'm going to go back up here, grab the equation. Now it's telling me undefined, okay? And the reason it's telling me undefined is, guys, look at what happens. If I took a 3 and I plug it into this problem, you would have a spot where x minus 3 would give you a 0 on the denominator, okay? There is no value there. There would be like an asymptote or something. So we're going to say that 3 is not a solution. So I'm going to go over here. This one is extraneous. My one solution is actually the negative 1/2. Okay. All right, guys, we are almost there. One more problem, and now I'm done. Okay. So this one is going to be a little bit interesting because we are working with a rational inequality. So let's do this. Okay. Okay. Very similar steps to the last one. Now, what I would say is for our on-level kiddos, you probably could just type this in the calculator and just replace the 0 with a y, and it would graph it and you would be okay. But AP, there's not going to be a calculator on everything. And so we've got to be able to deal with this stuff when that's not the case. And this is a little bit trickier because with it being an inequality, just some of the solving things get a little wacky if you do some of the similar tricks from equations. What I'm going to do, rather than multiply an entire equation by an LCD, is we're going to combine our fractions. So we're going to make our fractions get equivalent denominators and add them together, which is a little bit of a different approach to multiplying through the whole thing by an LCD. Okay, so you'll see what I mean. But I just made an extra note there because I think on level, we're just going to type it in and see what it looks like. But in AP, we need to make sure that we can actually solve it. Okay. Okay, so what we're going to do is we're going to first get common denominators. So the common denominator would end up being x plus 3 times x minus 1. That's just the easiest way to get the common denominator. All right, so what I need to do is for this first fraction, I need to multiply top and bottom by x minus 1. Okay, I'm going to rewrite this just so that you can see exactly what I'm doing, because a lot of times we do some math in our heads and it's not always clear writing. But this is what I'm doing is I'm taking this first fraction and I'm going to cause it to have a common denominator. We want it to have the denominator with x plus 3 and x minus 1. So in order to do that, I've got to multiply top and bottom by x minus 1 because that's the piece it's missing. Okay. Now this one is missing the x plus 3. So I'm going to multiply this one top and bottom by x plus 3. And I'm not changing the value or anything because all I'm doing is changing the way it looks by using equivalent or by multiplying by the same thing top and bottom. Okay, so we're going to multiply all this stuff out. It's going to end up giving us 5 times x minus 1. And then I'm going to go ahead and do this one over here, 3 times x plus 3. To save yourself a little space, you can go ahead and say, well, when I add these, they're going to have that same denominator, x minus 1 and x plus 3. So you can go ahead and write them as one big fat fraction, and this is all less than 0. All right, now don't start canceling stuff. It doesn't work that way from here. Okay, we're going to distribute the 5 through the parentheses. So this gives us 5x minus 5. Then we have plus 3x plus 9 over x minus 1, x plus 3. We're going to combine our like terms. So I have 8x plus 4. This is all over x minus 1, x plus 3. And this is where I'm going to say we're okay. All right. I don't think we need to be able to do more than this as far as like trying to solve it and get like an x on one side. Because what I want you to remember is when we were solving in example 1, we were able to plug it in a calculator and see what the graph looked like to get the range for what values x could be. And we're going to do something similar here, but we're going to use some of the things that we learned in 2.6 to tell me features about this. So I'm not just going off of a calculator, we're also going off of our brain, okay? All right. What I know is that we're going to have some asymptotes at this denominator. What we're going to do is I'm going to find some features, okay? We're going to say we got a vertical asymptote where x is 1, so the opposite of this guy, and then where x is negative 3, okay? Because when you solve your denominator for zeros, assuming that they don't cancel out and make holes, right, you're going to have that vertical asymptote. So those are some asymptotes. Those are values that x is not going to be able to be because those asymptotes show where the graph can't reach. We also can find some other things, such as like your x-intercept, okay? that's where the numerator equals 0. If I took 8x plus 4 and set that equal to 0, this is 8x equals negative 4, x equals negative 1/2. So I know that my x-intercept is going to be there. If I really wanted my y-intercept, I could get it, but it's not super important for a problem like this because unless you're just trying to see what the graph is shaped like, it's not super duper important. So what we're going to do here is I'm going to go ahead and jump over to looking at my graph, okay? And we have values. Remember, we have these asymptotes where at negative 1, 2, 3, I'm going to put those little dashed lines in here. We also have one at a positive 1. We said that it's going to hit the x-axis at negative 1/2. So it's going to hit our x-axis around in here, okay? And this graph, really, you're going to end up seeing, so we got these asymptotes, we're going to end up seeing an interesting shape. Now, I could have found my y-intercept. My y-intercept would be, in this setup, it would be 4 over the negative 1 times 3 would be a negative 3. So my y-intercept, if you really wanted it, it would have been where we have negative 4/3. Okay, I know that sounds kind of crazy, but you would divide the constants. Okay, so negative 4/3 is going to be down here a little bit in case you wanted that. So you can see a little bit more about the graph shape. It's going to be going down on this side. And coincidentally, it's going to be going up on the other side. Okay. We're also going to be shading the parts that are above this graph because we want y to be greater than this stuff. So you'll be shading the stuff that is above this. So it's not just this. Okay, this is just part of it, but there's other stuff as well, and you could always plug in more values to find them. This is the moment where I'm going to switch us over to our graphing calculator, and you'll be able to see a little bit more clear just because of the sake of time, because this is already getting to be a long lesson. So if I type this in, you can see this guy. Okay, there's actually a piece over here, and we would be shading this side. And then there's another one going kind of the opposite direction, but we're shading above it. Okay. So what we're looking for are those places where your x axis is shaded, basically. Okay. That would be everywhere from negative infinity up to this asymptote, which was a negative 3. Now, we're not going to include that as an answer solution. I'm going to put a parenthesis on that because it can't hit that asymptote. Okay, it does not hit the x-axis again. The shading doesn't until you get to this negative 1/2. So that's where we're going to pick back up. We're going to have negative 1/2, and it goes until the next asymptote, which is at positive 1. And then it will never hit the x-axis again. So this is what we're looking at as far as our range of values for what x can be. Okay. Now, like I was saying, if you are the on level, or even if you're in the AP and you have a calculator for this section, you honestly could have typed this in and set this just equal less than 0, and you would have seen a similar situation and been able to get these answers. So your graph may have looked a little bit different, but your solution should have been the same in the end. So anyways, all right, guys, that is it for 2.7. I will see you guys in the next one. Good luck.